This is the second of two tutorials on the topic of Prognostics-Informed Diagnostics in Express. In this video, we will look at how prognostic definitions can be used to modify the way in which a system's ability to isolate detected faults is evaluated within the Express software. In the previous video in this series, we looked at three ways in which Express can take prognostics into consideration when evaluating fault detection. These same three alternatives also apply when assessing fault isolation. First of all, when evaluating system characteristics that are related to the overall health management solution, prognosed failures should be included in the diagnostic analysis. For example, analysts may wish that both prognostics and diagnostics be taken into account during the calculation of certain maintainability metrics, such as the projected mean time to repair or system availability. On the other hand, when developing predictions of the expected performance of a system under diagnosis, then prognosed failures are often excluded from the diagnostic analysis. For instance, the analyst may wish to include only non-prognosed failures in the fault detection and fault isolation calculations used to satisfy contracted testability requirements. Finally, there are times when it will be desirable to assess diagnostic performance without taking prognostics into account, an approach that I often refer to as ignoring prognostics. This approach is useful when evaluating the diagnosis of critical failures, failures whose effects could be catastrophic if not properly identified. Before we look at how this works in Express, let's take a look at how fault isolation is calculated for each of these three approaches. The examples in this video will all use this four-box model. To keep things really simple, each of these boxes consists of a single function that can fail in a single way. Moreover, each box has been assigned the same failure rate, so that for each of the four functions, the relative failure probability is 25%. Also, we'll assume that diagnostics have been developed that are capable of isolating these failures into three fault groups. As you can see, if we ignore any prognostics that may have been developed for this design, then 50% of our failures will be isolated to the two fault groups that contain items A and D. The remaining 50% will be isolated to the fault group containing both objects B and C. So, when prognostics are not taken into consideration, diagnostics will be capable of isolating faults to a single item 50% of the time. Now let's see what happens to our fault isolation numbers when we take prognostics into account. Say that sensors have been developed that allow us to prognose all of the failures to box A with 100% confidence, as well as 50% of the failures to box B. If the prognostics were to perform in accordance with these estimates, then we would expect 37.5% of our faults to be prognosed. When we include prognostics in our diagnostic analysis, the fault groups that are identified by prognostics are accounted for in our fault isolation statistics along with the fault groups that result from diagnostics. So if, using this example, we look at the fault groups that contain a single item, we see that objects A and D are both isolated in full, one by prognostics and the other by diagnostics, and that half of B is also unambiguously isolated using prognostics. The remaining failures to B are isolated in ambiguity with the failures to C. And if we sum up the relative probabilities for the fault groups containing either a single failed item or a prognosed failure to a single item, then we see that we would expect 62.5% of our failures or pending failures to be unambiguously isolated to a single component. Now, this is definitely a more attractive number than the 50% isolation to 1 that we achieved using diagnostics alone. However, this jump in statistics is not due to any special prognostic superpowers. For most development projects that have system prognostic requirements, the development of the prognostics is notoriously time-consuming. I'm not saying that the time and money spent on the development and assessment of prognostic sensors is in any way wasted. The point that I'm trying to make here is that the performance of these sensors is often not known until late in the development process. The engineers responsible for the diagnostic analysis, which is typically performed long before prognostic performance details become available, must ask themselves not only whether they could use prognostic sensors to diagnose actual failures, but also whether they can count on prognostic sensor development being pursued and funded to completion. Some savvy analysts say yes to both these questions and proceed under the assumption that the diagnostics will make use of the sensors that are under development for prognostics. Other analysts are more cautious, preferring to generate only diagnostic assessments that they can hang their hat on, so to say, even if the numbers appear to be less attractive. Now, it's this latter approach that we assumed for these three examples. The sensor that's used to identify pending failures to object B was not used by the diagnostics. That's why when prognosed failures are included in the analysis, the fault isolation improved. Now, once prognostics have been developed, analysts can always go back and add additional diagnostic tests to utilize those prognostic sensors. Now let's look at the third analysis approach, the one in which prognosed failures are excluded from the diagnostic analysis. In this sample model, if we were to exclude those failures that are expected to be covered by prognostics, then we're left with three objects that collectively represent 62.5% of our system failure rate. Now, the first thing we must do before calculating the isolation statistics is scale the individual failure probabilities so that they add up to 100%. And when we look at how failures would be isolated by the diagnostics, we see that we can isolate to a single component only 40% of the time. So our overall isolation percentage is now 40%. Why is the number lower than our original detection number of 50%? Because item A, for which failures could be unambiguously isolated using diagnostics, has now been removed from the analysis since all of its failures could also be prognosed with 100% confidence. The exclusion of prognosed failures does not always result in less attractive isolation numbers, however. If failures to item A had not been prognosed, only those to B, then the numbers would have shifted in the other direction, since only the isolation to two items would have been reduced. Let's look at what would have happened if we had improved the prognostics on B so that 100% of the failures can be predicted in advance. With this change, we would find that we're able to always isolate failures to a single failed component. A testability analyst's dream, no doubt, but one that we know is riding on some hefty assumptions about prognostic performance. Now let's look at all this in Express. Here's the Express model for the same four-item design. Each item has a single function and failure mode, and all of them have been assigned a mean time between failures of 120 operating hours. The four items have also been assigned a variety of repair times, from 10 minutes to 5 hours. We've defined diagnostic tests at each output of the system and prognostic inspection tests for items A and B. Each prognosis has been assigned a horizon of 0, meaning that the prognosis will occur some unspecified time prior to failure. Also, notice that failures to item A can be prognosed with 100% confidence, whereas the confidence is only 50% when prognosing problems with item B. Now let's create a diagnostic study and then select our diagnostic test set on both the detection options and isolation options panels. We'll also set our isolation algorithm to use common cause isolation, since this is the setting most frequently used when calculating testability metrics for contract compliance. Because we've not selected our prognostic test set on the prognostic options panel, we will be ignoring prognostics completely during this run of the diagnostics.